Hello, hello. My name is Jakub. I work at Oli Garden as a software engineer. And in today's live session, we will be exploring the best practices, patterns, and anti-patterns in spans and traces instrumentation using Open Telemetry. So as you may see, I can't see my presentation on the screen. Oh, yeah, there it is. Thank you. As you may see, the subtitle of this presentation is Stop Creating So Many Spans. And some of you may ask, aren't spans supposed to help us with observability? Shouldn't we create more? And I think this is the misconception we are going to tackle today. So let's get started. This is the Jagger UI. Jagger UI is a traces backend that allows ingestion and UI for traces. So this is the certain trace that we'll be working on today. As you may see, I believe some of you may squinting your eyes and just can't see anything. And that's the whole point of this presentation, because it's really hard to see what's going on there. I also prepared, this will be better. I prepared the text representation of the span, so it's actually readable. So as you may see, we got the parent span, process payment, the set amount, set currency, a lot of those small spans that takes nanoseconds, also spans for validation that takes nanoseconds. And it's really hard to see what's wrong, what's bad, how do I work with this trace. And yeah, this is really the problem. So I can't find the information on the trace. And another problem is the cost. So at certain scale, in my calculation, I use 10,000 requests per minute. We will be creating $5,000 per month just to handle this type of traces, handle ingestion and storing. And this is huge because, well, I don't need that. I will prove you that you don't need this many spans to trace this type of workloads. How it should look like, we will get there at the end of the presentation. This is the sneak peek. So as you may see, we only have three spans. We have this root span, we have the insert payment span, which does, I don't know, Postgres operation, as I can read it there. And we also have the span with the API operation. So let's get started. Let's show patterns, anti-patterns that will help us go from this view to this one. So let's get started. The first anti-pattern that I spotted is dynamic names in spans. So as you may see, I'm creating a span for processing payment, and I want to improve my observability, and I actually want to include the payment ID so I can backtrack this payment in my database later. And I include it in my span name, which is very wrong. Why it's wrong? I won't go deep. I won't dig deeper into how Jagger store those traces, but we can say that each span is a separate index that Jagger tracks. So we should think more about those operations as a single operation or unique operation your service does. So how it should look like? It should be just a simple process payment without any additional templates. We can do set attributes to store this payment ID. We have a blog post on our Oli Garden page by Juracy that explains how to name your spans, and you should really read it, and you will learn everything you need there. So let's move on. We've got setter spans. This is another pattern that we'll cover there. So you have some information in your trace. For example, the payment amount. You discovered that the payment amount is 157. And you want to do the good observability, and you want to track this value somewhere. And what you do, you create a span that sets amount. You set the amount to the using set attribute, and you do this for the other field, for example, the USD. For example, the currency that is set to US dollars. And what you did, you just created two spans to track instant in-memory operations. And how you should do it better, you can just extract span from the parent span. This snippet is from Golang code. I believe other instrumentations also have similar flow. You just get the parent span, you set the attributes there. You created no new spans, you get the same information as before. Next, similar one, the error spans. You don't have to track the information, but you have to track the error. So in the bad pattern, what you did, you created a new span called validate payment that record an error if the validation was bad. You record an error and you end the span, and that's what you did. You just created another span to capture this information. What you can do instead is you can capture. Actually, what you can do is you can just return an error, and that's easier. I think this is a wrong example in my presentation. Sorry for that. So the validate payment could return an error, and this is what we see. We are recording an error on the parent span. If you want to be explicit, we can also use the add event that will tell that the validation was completed. And this is free. The event is just the metadata of the span. So next anti-pattern is the batch operations. So you got some kind of slice of items to process. And in this example, you want to set the price of each of those items. So you start the new span, you set the attribute to the price, and you end the span. And yeah, this is the n+1 problem in our span instrumentation. You got the similar issue when you work with database queries. So you do a first query, and for each item you want to process, you do another query. This is really, really similar. What you can do instead, you can just capture the aggregate of your batch operation. So how many items you process and what's the total amount. This is just a single event with attributes. If you want to be explicit and capture every one of those items, you can also use events. So events are really, really lightweight operations of the spans. I will explain it later, how actually events works. Next pattern, the HTTP middleware explosion. So what it does, a lot of HTTP application use the middleware pattern. So you plug a function in every that is being run before every request. For instance, here we need to capture the user agent that came from the headers. And since we are doing the tracing, we also want to capture it in our trace, in our span. So what we do, we create a span, extract user agent, and we capture this attribute as a parameter. And we just created a span to capture this operation, to capture the header get operation, which takes nanoseconds. What you can do instead, we also see it before, you can just extract the span from the context, extract the parent span, and set the attribute there. One thing that you should have in mind doing this, probably the auto-instrumentation libraries for HTTP servers will create those root spans for you. What you must think of is that those auto-instrumentation middlewares go before these ones. So this span is actually created, right? Yeah, next example, the function wrapper spans. This is also what I've seen in code bases. So you got this the service, repository, and database layer, and you create span in every of those functions because, well, this is what people do. And you got the span payment service safe payment, you got payment repository safe payment, and you got finally the DB wrapper insert. And you got free spans for a single transaction that is a DB call, and that's how it could be done better. I believe you don't need spans for those service and repo functions. You just need span at the IO boundary with all the attributes you need. Yeah, what you can do to move forward with this, you could really get familiar with the open telemetry semantic conventions. So when you read that the database system, there's such attribute in semantic convention or DB operation name, it will be easier for you to model those spans. So you know that you can include the operation in the, for example, the collection in the attributes. You don't have to create a span. So yeah, really get familiar with those two, with database conventions, HTTP conventions. There are more, but I believe those two are the most common ones in the in all of the apps we are building, right? Yeah, so this is what we end up. I'll give once again this wrong trace there. This is what we get before. We applied all of those patterns to improve our telemetry. And this is what you have at the end. We got three spans. We got the root span that has all the metadata related to our process payment. So we got which order, how much actually people pay for that, which user actually triggered that. We've got some events, for example, that the total amount was calculated, then actually we derive those values to the parent span. We got another span for the database operation with all the rich attributes, and also the span for the HTTP call. And we can see that we made it to the stripe, and it was successful, and it was for this amount. We've got all the same information we had in the 60 noisy spans, but right now we have 2 rich, meaningful spans that have all the metadata you need. Yeah, so what framework you can apply to go beyond those patterns? Use the variability principle when you have to create a span. So ask yourself a question, is this operation unpredictable? If it is, and it will usually be a database call, the HTTP request, or any other I/O operation, you probably need a span for that. Otherwise, you can just use attributes or events. What are attributes? We saw those here. Those are just metadata tags, labels, or key value directories on the span. And they're pretty cheap. You can search with them using, for example, the Jagger backend. And yeah, they provide a little cleaner traces because you don't have to create that many spans to capture the same information. Also, events are not indexed by the backends, so they are really cheap, and they are just a metadata for the span. So you can track, for instance, this process of creating the payment by not creating additional spans that you must pay for. But I mean, those attributes are not free. There's so information to store, but they are way cheaper than spans. Yeah, so that will be it. I had in this presentation one quote you got there. Your traces should tell a story, and I think this is what you should have in mind while designing your tracing, and your spans and your observability. If you have any questions, I'm happy to take them.